Okay, so I am looking at page 194, and we're looking at this table of molecular geometry. And I find this reference table to be really useful. Not only can you use it to identify molecular geometry, the name and the generic formula, but you can also use it to identify hybridization of your central atom. So remember that the geometry of a molecule dictates the hybridization of the central atom. And what I want you to notice here is this column in your table where it says orbital hybridization, and you can see that these are organized based on that hybridization of the central atom. Now the thing that you're going to find yourself doing, and the type of question that you get related to orbital hybridization, is the question is often asking what is the hybridization of a given central atom in a molecule. The way you go about identifying the hybridization of an atom in a molecule is you figure out first its molecular geometry. Once you know what the molecular geometry is, you can use this table to say what the hybridization has to be. So for example, let's say that you had a molecular geometry of trigonal bipyramidal AB5. You would say that the hybridization of that central atom has to be sp3d. You have to have 5 equivalent hybrid orbitals to represent that trigonal bipyramidal geometry, and you get that by using d orbitals in your hybridization. You can pull the hybridization just off this table. So let me show you an example of how I'm going to use this table. And you guys are going to see that I'm giving you a separate copy of this reference table. And if we were in class, I would give you another cardstock reference sheet with this table too of your molecular geometries on it, so that you can keep it handy and you can keep referencing it as you're doing problems. So bear with me, I'm going to flip ahead to where we left off in our notes, and I want to do some practice problems with this hybridization. So I'm going to look at the bottom of page 200, and I'm following these steps here to assign hybridization to any central atom in a polyatomic molecule. And you'll notice here we're following these repetitive steps. First I need a Lewis structure, then I need molecular geometry, and then I'm going to use that table, table 2, to say what the hybridization is. Now I think you guys are going to find this fairly straightforward. I'm just going to do one example here, and I'm going to leave the other ones for you to work on and check your answers. The one that I want to look at is ammonia NH3. So I'm going to follow the steps. Step 1 is draw a Lewis structure. So let's see, nitrogen has 5 valence electrons and each hydrogen has 1. So that gives me a total of 8 valence electrons. Nitrogen's in the middle, and I'm going to draw 1 bond to each hydrogen. That used up 6 valence electrons, and I have 2 left. Those 2 remaining valence electrons, I'm going to give them to nitrogen to complete its octet. So nitrogen has a lone pair. And I'm done. I've got a good Lewis structure. Nitrogen has an octet. The hydrogens have duets. Next, I'm going to take that Lewis structure and I'm going to translate it into a generic formula so I can predict its molecular geometry. So nitrogen is my central atom. It's bonded to 3 hydrogens, so I'm going to start off AB3. And I've got 1 lone pair on nitrogen, so it's going to be AB3E. Next, I'm going to go to that reference table on page 194, table 2, and I want to know the name of this molecular geometry. AB3E represents pyramidal geometry. All molecules that have this pyramidal geometry have to have the same hybridization around the central atom. There needs to be 4 lobes of electron density that are equivalent to one another. 3 lobes are used to form my 3 bonds, 1 to each hydrogen. The last lobe contains that lone pair on nitrogen. The hybridization for all molecules that are pyramidal, you guys will pull this off of your table. Nitrogen in this case is sp3 hybridized. And that's my answer here for this practice problem. If I want to know what's the hybridization on nitrogen and ammonia, the answer is that it's sp3 hybridized. So I'm going to stop this video here, and I'd like you guys to check your work on the remaining examples on this page.